In problem number 38, we're looking for the line that is tangent to the curve f of x equals 1 over square root of x minus 1, but it's also parallel to the line x plus 2y plus 7 equals 0. And since it's parallel to that line, x plus 2y plus 7 equals 0, that means it has to have the same slope as that line. If we were to solve that linear equation for y, we'd see that it has a slope of negative 1/2. So that means we need to find the place on the curve of 1 over square root of x minus 1 where the derivative is negative 1/2, because that is the slope of the tangent to the curve at that point. And then we'll find the equation of that tangent line. And so we start with the limit definition of the derivative, and we substitute in the original function x plus delta x wherever we see x. And so f of x plus delta x will be 1 over the square root of x plus delta x minus 1 minus f of x, which is 1 over square root of x minus 1, and that's all divided by delta x. Now, because this is a complex fraction, we can't go any further until we simplify that. And we do that by multiplying numerator and denominator by the least common denominator of the rational expression in the numerator. And that is square root of x minus 1 times square root of x plus delta x minus 1. And so in the numerator, we need to distribute that to both terms. And when we do that, we have the limit as delta x approaches 0. The first term simplifies to square root of x minus 1, then minus, and the second term simplifies to square root of x plus delta x minus 1. And that's all over delta x times square root of x minus 1 times square root of x plus delta x minus 1. Now we're ready to apply the conjugate method to simplify the numerator. And so we'll multiply numerator and denominator by x minus 1 plus the square root of x plus delta x minus 1. Now when we do this in the numerator, so the numerator is a difference of two squares, so that'll be first term squared minus second term squared, or x minus 1 times, or x minus 1 minus the quantity x plus delta x minus 1, while the denominator is delta x times square root of x minus 1 times square root of x plus delta x minus 1 times the quantity square root of x minus 1 plus square root of x plus delta x minus 1. Now the numerator simplifies to x minus 1 minus x minus delta x plus 1. And so the x's are 0 pairs, negative 1 and positive 1 are 0 pairs, leaving negative delta x over delta x times square root of x minus 1 times square root of x plus delta x minus 1 times the quantity square root of x minus 1 plus square root of x plus delta x minus 1. The delta x's cancel, leaving negative 1 in the numerator, so we have the limit as delta x approaches 0 of negative 1, and when we substitute delta x equals 0 in the denominator, we end up with square root of x minus 1 times square root of x minus 1, which is just x minus 1. Then times square root of x minus 1 plus square root of x minus 1, which is 2 times square root of x minus 1. And if we write square root of x minus 1 as x minus 1 to the 1/2, and x minus 1 is x minus 1 to the 2/2, then this finally simplifies to negative 1 over 2 times x minus 1 to the 3/2. And that is our derivative. And that's what we want to set equal to negative 1/2. And so we want that derivative to equal negative 1/2. And since we have negative 1 in both numerators and 2's in both denominators, that means that x minus 1 to the 3/2 has to equal 1. And that means that x minus 1 has to also equal 1. So that means that x is equal to 2. So up to this point we have our slope, we have our x sub 1, we need y sub 1, so we're going to take that 2 and plug it into the original function. 1 over square root of 2 minus 1, just 1 over square root of 1, or y is equal to 1. So y minus y1 equals m times x minus x1. Plugging in our values, we get y minus 1 is equal to negative 1/2 times the quantity x minus 2, or y equals negative 1/2 x plus 2. On the graphing calculator, we enter our function, we graph it, we have second draw tangent at x equals 2, and that's our equation.